Assalamualaikum and welcome to our video. We are from Group 18 will present about Mission 3. This is the list of our group members. The purpose of this video is to teach about the first topic, which is pulse modulation, and second topic, which is multiplexing, where both of these topics are related to Mission 3. So, what is pulse modulation? By definition, pulse modulation are one of the type of modulation where the signal will be transmitted through pulse signal. There are four types of pulse modulation. The first one is pulse amplitude modulation, PAM. Second is pulse width modulation, PWM. Third is pulse code modulation, PCM. And lastly is pulse position modulation, PPM. Before we going into the detail with the type of pulse modulation, we're gonna start with sampling theorem. In sampling theorem, there are three things that need to be highlighted. The first is proper sampling, second is improper sampling, and lastly is the sampling method. Proper sampling is when the analog signal can be reconstructed using sample. Analog signal, which is the solid line, will be changed into the digital signal, which is the square, through sampling. The left one is the proper while the right one is the improper. We can see that in the proper sampling, we can get back the analog signal using sample. However, for the improper, we will get different analog signal if we use the sample. So why is it improper? The answer is because it don't follow the Nyquist and Shannon theorem, which resulted in different result of analog signal based on the sample we get. What is Nyquist and Shannon theorem? Shannon theorem states that sampling frequency must be greater or equal to twice the modulating signal frequency. In short, Fs is greater or equal than 2 FM. While for Nyquist theorem, sampling frequency must equal to twice the modulating signal frequency, or in short, Fs equal to 2 FM. For the sampling method, there are three, which are ideal, natural, and flat top. In practical, it is harder to get the ideal sampling. By using ideal and natural, error can be eliminated, but for flat top, it is not the case. For pulse amplitude modulation, the amplitude of the pulse signal, which is PT, adjusted based on the amplitude of the modulating signal, which is MT. The advantages of using PAM, it has high efficiency and not complex. However, for the disadvantages, it requires larger bandwidth and also require more power. The application of PAM is controlling signal of microcontroller, Ethernet communication, and photobiology.
In previous part, you already heard about what is sampling method and PAM, pulse amplitude modulation. In this part, I will talk about another pulse modulation, that is pulse width modulation, PWM. PWM is a modulation technique that generates variable wide pulse to represent the amplitude of an analog input signal. PWM used in the telecommunication for encoding purpose, for example, bulk diving, motor speed control, and ultrasonic cleaning. The reason of PWM is choose to done this application is because of PWM has these two advantages. First advantage is energy efficient and power saving. PWM offer energy efficient and power saving benefit for adjusting the width of pulse to regulate the power transfer. This technique eliminates the need for energy wasting, register, and provide power on demand. Second advantage is precise control and flexibility. PWM LED application can be adjusted to complete the duty cycle of the pulse. Of course, they also have several disadvantages of PWM. The first disadvantages of PWM is it increases the switching frequency and stress of the power device. It reduces the lifetime and increasing its switching loss and several EMI emission. Next is produce audible noise. This can be undesirable in noise-sensitive environment or application where need in quiet operation. During modulation, we need to encoding the signal of audio to digital, and it is called quantization process. When we sampling the signal, we will arrange the amplitude of signal into several levels. Let's take a sinusoidal signal, split the amplitude into 8 levels. Then the sample point will stick with the level of measurement, and that's how the pulse is generated. The concept of bit depth is come from the number of bits of information in each sample. The reason I introduced it because it is important in the next section. The bit depth is important because during the transmission, the cable has a limit. Only below the limit, the transmission can carry on. Finally, I will talk about pulse code modulation. Previous part we talked about sampling, bit depth, quantization, modulation, and Nyquist theorem, and when they all combine, it will become PCM, pulse code modulation. The idea of PCM is come from during PWM. During PWM, massive resolution is needed, but each sample amplitude can be expressed as 16 bits binary number. We can encode the series binary itself and become pulse. That's how pulse code modulation come. We make pulse at 1 and absent of pulse at 0. And here is how the PCM is look like after we done all the process that we need.
Next, we'll be talking about pulse position modulation, which is a modulation method where each pulse in the carrier pulse sequence changes only in time, while maintaining the same shape and amplitude throughout the signal. Moving on, we'll be talking about the advantages and disadvantages of pulse position modulation, or we can call it PPM. For the advantages of PPM, the first one is noise immunity. PPM has better noise immunity since noise typically affects the amplitude rather than the position of the pulse. Next is the advantages of pulse position modulation. First is complexity. The next one is they required more bandwidth. Next is the application of PPM. The first one is optical communication. For example, optical fiber. The next one is remote control system. For example, television, DVD players, air conditioner, and other household appliance. And the last one is aircraft navigation. PPM is used in various communication systems for aircraft navigation, providing reliable transmission of navigational data. Next, we'll be talking about multiplexing. Multiplexing is a process of transmitting two or more signals at the same time in the same medium. And the objective of multiplexing is to increase the capacity of transmission channel. There are several types of multiplexing. The first one is frequency division multiplexing, which it transmits different signals on different frequency channels within the same bandwidth. For example, traditional radio and TV broadcasting. The next one is wavelength division multiplexing, WDM. It combines multiple optical signals at different wavelengths into a single fiber for transmission. WDM is an application of FDM within optical medium. And the last one is time division multiplexing, TDM. It transmitting multiple signals over a single transmission channel in different time slots, each dedicated to a different signal. For example, data and satellite communication. Next, we'll be talking about the advantages of multiplexing. The first one, more signal can be transmitted by a single medium, which can be related to the efficient use of bandwidth. By combining multiple signals, multiplexing ensures that bandwidth is utilized more efficiently by reducing the occurrence of unused capacity. The last one, I'll be talking about the benefits of improvements in telecommunication technology. The first one is increased work efficiency by enabling the faster communication, better collaboration tools, and streamlined processes. The next one is the ability to enjoy the benefits of enabling remote work. By having remote work, it enhancing work-life balance as it allows employees to work virtually anywhere. The last one is cost reduction. Multiplexing reduces the need for multiple physical transmission lines. For example, instead of using separate lines for each signal, a single line can carry multiple signals, lowering installation and maintenance cost. Data will be processed quickly and efficient systems consume less energy.